If you tried to count every star in the universe, one per second, without stopping, you'd die before you finished the first galaxy. And there are 2 trillion galaxies. This is how big the universe really is. And your brain isn't ready. Let's start simple. Light is the fastest thing in existence, 300,000 kilometers per second. Nothing can go faster. Light from your phone hits your eyes instantly. From the sun to Earth, 8 minutes. Seems fast, right? Now imagine this. There's a star called Betelgeuse. It's 700 light years away. When you look at it in the night sky, you're seeing light that left when the printing press was invented. Betelgeuse could have exploded 600 years ago. We wouldn't know yet. The light from that explosion is still traveling. But that's nothing. The Andromeda Galaxy is 2.5 million light years away. The light you see from it tonight left when early humans were figuring out stone tools. If an alien civilization in Andromeda looked at Earth right now through a powerful telescope, they'd see dinosaurs. We're looking at the past, always. Everything you see in the night sky is ancient history. And here's the part that breaks your brain. Some of the galaxies we're looking at don't exist anymore. They're gone, dead. But their light is still reaching us, like ghosts crossing the void. The universe is so big that light, the fastest thing possible, isn't fast enough. The observable universe is 93 billion light years across. But wait, the universe is only 13.8 billion years old. How can we see 93 billion light years in any direction? The math doesn't work. Here's why. Space itself is expanding. Not just the stuff in space, the fabric of space. Imagine dots on a balloon. You blow it up. The dots move apart, but they're not moving through the rubber. The rubber is stretching. That's the universe. Galaxies on the edge of the observable universe aren't just moving away from us. Space between us and them is expanding so fast that their light will never reach us. There's a cosmic horizon. Beyond it, light can't catch up to the expansion. Those galaxies are lost to us forever. And here's the truly terrifying part. We don't know what's beyond that horizon. The universe might be infinite. It might loop back on itself like a sphere. It might have an edge. We don't know. We're trapped inside a bubble 93 billion light years wide, and we can never see what's outside. Think about that. You're standing in a room with no windows. The walls are moving away from you. You'll never reach them. You'll never know what's beyond them. That's where we live.
Here's something even stranger. 95% of the universe is missing. We can see stars, planets, galaxies. We can measure their mass. But when scientists calculate how the universe should behave based on what we see, the numbers don't add up. Galaxies spin too fast. They should fly apart, but they don't. Galaxy clusters are held together by gravity that shouldn't exist based on visible matter. So scientists came up with dark matter, invisible matter. We can't see it, can't touch it, can't detect it directly. But it's there. It has to be. It's 27% of the universe. And then there's dark energy. Even weirder. The universe isn't just expanding, it's accelerating. Something is pushing space apart faster and faster. We don't know what it is, we just call it dark energy. It makes up 68% of the universe. Add it up. Dark energy, 68%. Dark matter, 27%. Everything else, every star, planet, atom, every human who ever lived, 5%. You're made of the rarest substance in the universe. The stuff that actually matters is almost nothing. We're a tiny footnote in a cosmic book we can't even read. Let's talk numbers. Real numbers. There are 100 billion stars in the Milky Way. That's more stars in our galaxy than people who have ever lived on Earth. There are 2 trillion galaxies in the observable universe, each with billions or trillions of stars. If you tried to count every star, 1 per second, it would take 10 quadrillion years. The universe is only 13.8 billion years old. You'd need 700,000 times the age of the universe just to count them. And that's just stars, not planets, not moons, not asteroids. Now think about atoms. Your body contains about 7 octillion atoms. That's a 7 with 27 zeros. The observable universe contains about 10 to the 80 atoms. That's a 1 with 80 zeros. These numbers are so big, they lose meaning. Your brain physically cannot comprehend them. But here's the worst part. The observable universe might be a tiny fraction of the total universe. Some theories suggest the universe is infinite. Others say it's one of infinite universes in a multiverse. If that's true, then everything we've talked about, all 93 billion light years, all 2 trillion galaxies, all 10 to the 80 atoms, is basically zero compared to infinity. We're not even a grain of sand on a beach. We're a single atom on a grain of sand on an infinite beach. So how big is the universe really? Too big to measure, too big to see, too big to understand. And yet, here we are, on a tiny rock, orbiting an average star, in a typical galaxy, in a vast cosmic web. Every problem you've ever had, every worry, every fear, every heartbreak, all of it happened on a pale blue dot in an endless ocean of space. Does that make your problems meaningless? Or does it make every moment precious? If this changed how you see existence, subscribe. We're exploring the cosmos every week, and trust us, the universe has more secrets to break your brain.